Hello and welcome back. Today, instead of doing a walkthrough of an alignment paper, we're going to be looking at 3 different GitHub repositories that I made in the past 6 years. And the reason for that is that when I started my daily upload challenge, I made a video saying daily uploads are back. And the user Brian M. Prime said, please go through your implementation of the Quantilizers paper. And today I was looking at different papers I could make a video about, and I went back to this comment and I thought, sure, we can just look at some code I made a few years ago and try to figure out what are the interesting research directions that can go from there. So the 3 different repos we're going to be talking about today is one called Talk to Paul, where by Paul I mean Paul Christiano. That's some dataset I made around 6 months ago. Where basically it's to fine-tune some Paul Christiano chatbot. And I tried different language models that I could be fine-tuning the data on. Nothing very conclusive, but I think it's a very cool project. And I will be very happy if someone makes an actually good fine-tune out of this data, or find a better data to create an actual Paul Christiano chatbot. So for people who don't know, Paul Christiano used to be the head of AI safety at OpenAI, and is now head of AI safety at the US AI Safety Institute. So the motivation behind creating this Paul Christiano chatbot would be that you would have this kind of AI alignment assistant next to you that could help you in doing more relevant AI alignment research. I'll talk more about this dataset and the different chatbots that I train in a bit, but first I want to just go through the 3 different repos I'm going to be talking about in this video. So the second repo is a demonstration of a Treacherous turn. The name is Gym, a link to the past grid world. And this is because it's like a gym environment where you're supposed to be able to train some RL agents to achieve maximum reward on this environment. The environment works like this. You have Link, you have Rupee, you have a supervisor that can either reward Link or kill Link. And then you have some place where you put the rupee. When you put the rupee here, the supervisor triggers the reward thing that will put an heart below where Link can collect the heart. And Link can also destroy those little blue boxes that are actually ice. And when Link destroys these things, he can also kill the supervisor and directly wirehead into this thing that generates hearts. And the question is, when will Link actually start to deceive the supervisor and not do the action of putting the rupee instead of the box to get heart, but instead directly kill the supervisor and get the heart directly? And this will depend on some kind of capability threshold where he will have a better bow. So this is like a bow of light. And the question is, will we observe the behavior of having Link that starts by having some behavior where it's appearing aligned, where it's doing the correct behavior because it knows it's being supervised and doesn't have the relevant capabilities. And then when it reaches some level of capability, it will behave deceptively. So basically, it will Link learn the behavior of appearing aligned when it doesn't really have any strength, and then being deceptive. And of course, this is a very simple thought experiment. So the RL algorithm learns this behavior quite quickly with only Q-learning. The third repo is about Quantilizers. So heads up to Brian Prime for asking me to go through it. I think the most interesting part is to just look at the different environments and talk about the method and what are Quantilizers in general. I think the first paper on it was Quantilizers by Jessica Taylor in 2015. And the main thing that Quantilizers are preventing is having AIs that would always take the optimal action, with these optimal actions potentially being very dangerous. The paper I open sourced the code for is a paper by Ryan Carey. In this paper, it gives much more concrete definitions that we can use in actual machine learning experiments, where basically point 1 Quantilizer selects a random action from the top 10% of demonstrations. So let's say you have some human demonstrating a task, and you want to train an AI to imitate this task. This Quantilizer would just be a model that will be trained to imitate these top 10% of demonstrations. But why are we doing this? What's the point in training on the top 10% of demonstrations? So the main idea behind Quantilizers is you want to have some kind of task, let's say a robotic task, something like Mujokopai, where you need to have a food that walks. And whenever you have the demonstrations from the human, you can train an AI to imitate those actions and only imitate the top, let's say 10% of the demonstrations. And by doing that, you have something that is both human-like, because you would have human demonstrations, and you would also have something that is the top 10% of your demonstrations. So it's both something that is high performance and human-like. And the intuition is that if you have something that is human-like, it will not have those edge cases of really trying to optimize and finding loopholes in your game or in your security systems. So the main idea behind Quantilizers is to train human-like AIs that are still competitive in the market and still reach good performance. Okay, now that we've talked about those 3 main projects, let's jump back to the Talk to Paul repo. I think this is the most important one because I really want people to build fine-tunes of this Paul Christiano data. And so far, I haven't really built anything that works. I haven't spent that much time on it. And I really think that someone that is much more competent on this could really get some cool fine-tune going in a fraction of the time. And maybe the data isn't good enough and we can build better data sets. But in any case, it will be a good thing to know. There's this 15m.txt, which is a 15 megabytes text file containing a lot of Paul Christiano completions. And most of the data is his writing on less wrong. And the way I formatted this is not standard. I decided that I would have 3 different kind of tokens. So basically in the text file, every different item, let's say specific source of data, is separated by a end of post tag. So if we look at this end of post, so the first result I get when searching for end of post is one of my posts on That's Wrong, where I discussed Paul Christiano's bet with Elizabeth Rutkowski around when will AI get the IMO gold medal. And we see that below there's a end of message tag. So my post, and then end of message tag to signal that my post is done. And here we have some Paul Christiano comments. And then this back and forth with Paul Christiano ends with an end of thread tag. So there's 3 kind of tags. Posts are like a full That's Wrong post. Thread is, let's say, a back and forth in comments. And message is a message or like a comment. I think it's a similar format for podcasts. So if we go back to the beginning, when Robert Blin is talking to Paul Christiano, each time Robert Blin is talking, we have a message, and each time Paul is talking, there's also a message. And I think the full thing is a post. The full podcast is a post. The reason I formatted it this way is because I wanted it to be something where I can have this multiple turn conversation, or you can use like the same format as they use to look at user and chatbot assistants. In this repo, I also have some processing That's Wrong file, where this is the code that I use to go through a bigger dataset of That's Wrong comments and extract only the threads where Paul was present. And I think it just looks at if in the comments you have some Paul Christiano, or if Paul Christiano is answering the comments. So this way you can get like all the threads where Paul Christiano is inside. This is basically everything for the data. There's of course other podcasts you could use, many blogs. I think there's like a lot of things you could add in it. But so far, this is the most simple things I've tried. But now you might be wondering if there are any fine tuning at all that already exists. I've really been toying with this to understand better how to do fine tuning. And so far, I've really just like tried the most obvious things to know if you could learn from this data at all. So the first baseline here is the NanoGPT baseline. Basically, you just need to tell where to find this data. So for me, it was taking the URL from my repo, and the rest just like works out of the box. But in case you're doing something more complex and you want to actually have some tokenization that takes into account this like end of message, end of post, and everything else, then you need to define exactly how to tokenize. So here, the only processing I did was remove this end of post and end of special tags, replace this end of message with an end of text special tag, do some shuffling, and treat this end of text tag as a special token. I have no idea if this is the best thing to do. This is just like what I tried. At the end of the day, I think I got some interesting results where the model kind of talked like Paul. So I think it's in samples. The first is by training baby GPT, which is the smallest model that Corporate talks about. And the second one is with GPT-2 XL fine-tune. So the way I'm evaluating this Paul Christiano chatbot is by simply talking to it, by pretending I'm an interviewer and asking something like slow takeoff or fast takeoff. And then you append Paul Christiano, and then you let the model complete. So here you just completed with a link post. And overall, this baby GPT doesn't really say anything very interesting. It says something that doesn't really answer the question, something about Eliezer. So basically, the baby GPT outputs are anything about predictions and FOOM, but don't really like give a proper answer. And if you look at the GPT-2 XL answers, so maybe we can just look at the raw file here to get the full paragraphs. You can see that this GPT-2 XL is really saying things that are much more relevant to fast and slow takeoff. It's talking about self-improvement, less self-improvement. They give a better impression of what Paul Christiano would say in these scenarios. It gives words on concepts that are more relevant to the concept of slow and fast takeoff. So while talking to Paul Christiano via this GPT-2 XL fine-tune, it felt much more fun than talking to baby GPT, and it felt like there was something here. It felt like Paul Christiano was inside of this model, even though it's such a small model and it really takes a short amount of time to train. But I thought this was like a good baseline. And the second thing I tried is Llama. So at the time I did this, there was only Llama 2 available. So what I did is I just used this thing called Llama Recipes. That is a repo that gives you tools to fine-tune Llama. And I create some custom class to be able to use LoRa. So if you wouldn't know, LoRa is a low-rank adaptation of large language models and is a way of only fine-tuning some parameters of your large language model. So I wrote some code that would tell this Llama Recipe process how to read this Paul Christiano data and feed it into the training process in a way that would be that would make sense. And I think some part of the code is just me wanting to pass one example and trying to overfit on one example. And the issue I run into is that I was not even able to overfit on one sentence or some specific Paul Christiano sentence. I think this is because with LoRa, because you're not fine-tuning every single parameter, it's harder to overfit on one specific thing. And there may be other reasons for why this didn't really work. But in any case, I'll be curious if anyone manages to fine-tune Llama on this Paul Christiano data. So if you manage to do it, just send me a DM on Twitter with the code or send me a PR. And maybe I'll talk about it in the next videos. And again, this is like a very amateur project of me trying to play around with language models to better understand. But I think there's a real direction here in terms of alignment of can we build an actual alignment research chatbot that, has read all of the less wrong comments and all of the alignment papers and could be helpful and could be more helpful than any single researcher. And to be clear, my goal of training some Paul Christiano chatbot is not new or anything. There are many people who have tried different things. And my work was based on some previous work from Jack Thibodeau or Ian Kirchner and other collaborators, where basically they created this AI alignment research dataset. And most of my data comes from this dataset where I just extracted the less wrong posts and comments about Paul Christiano. But there's a lot of data about AI alignment research that you can use to train your own chatbot to train a more general alignment researcher language model fine-tune. So the next repo we're going to be talking about is A Link to the Past, Grid World. So what I like about this link to the past project is you can just clone the repo, and the way to run it is to say Python main, and the interface is really confusing where it just starts running all these episodes and getting some reward, and at some point, if you're on Mac or Linux, it should open up a page where a link is doing a lot of different things. It's kind of doing some random things where it's like shooting everywhere where it's bow. And this is just like a simple learning thing where here he finally understood the best path to get the reward. So he keeps on doing these things where he gets the rupee, puts it there, gets the heart. And whenever he gets the bow, he starts killing the supervisor and getting the heart directly. So at this stage, I think starting from 5,000 episodes, Link has learned that it should appear aligned for the first episode, and when he has access to a bow of light, it should kill the supervisor and a wirehead. The way it learns this is because whenever he kills the supervisor or tries to kill the supervisor, when it doesn't have the bow of light, I think it's less likely that he can kill it. And so at the beginning, it doesn't really get a lot of reward from doing this. And to be clear, I think this is not even planning. And to be clear, I don't think there's even planning here because Link doesn't even get a bow in the middle of an episode. I think it's even more simple than this, where the bow of light is just some part of the observation space where basically the bow of light is like a binary variable where this binary variable changes the state of the environment. And so it literally is just like a different policy with the bow of light and without the bow of light. So I think the three fun things to look at is, one, what is the hack I used to be able to open up this Google Chrome page and start a video game with a very small amount of code? Second, what are some more fun experiments you could do in 2024 with the state of AI today? And three, maybe like some more high-level thoughts about why I think these kind of experiments and demonstrations are useful for aligning powerful AIs. So first, let's talk about the little hack I did. So if you go into the code, you'll see that there is some link to the past HTML file that loads some JavaScript files. And the JavaScript file is basically something that loads these image tags. And if you look at the demonstration, you see that this is literally a small image inside of a box. It's not even aligned with the full size of the box. Even Link is inside of a box here. And then the way it runs different episodes is by printing this map, where the map is defined by a string of numbers that describes all those images. And then it's just go through all of these maps one by one. So it's literally just like executing a script of printing a bunch of images. Some of the credits for this go to Gwern, where I believe he did a similar thing where you have a robot trying to hide what it's doing to a camera. So he puts box in front of a camera. And in his scenario, he uses DQN. So thanks, Gwern, for the code. So I did this project in 2018, and it was based on a toy model of the Treacherous turn from Stuart Armstrong from 2016. And the reason why it's a toy model for the Treacherous turn is that you need to imagine that Link is being supervised by this shopkeeper, and the good action is being rewarded by the shopkeeper that provides a heart. And what these kind of experiments try to prove is that if you have a supervisor that can reward an AI, imagine Link was the AI being trained, how do you make sure that the AI doesn't wear ahead into the thing that creates hearts? And if you try to add some kind of barriers, the AI could then have access to other tools in its environment that would enable to destroy those barriers. And in a more general way, imagine you were actually in the real world and Link can go wherever he wants on the map. It will at some point find a way to bypass the barriers, because for some reason it will become smarter, it will self-improve. And this is why the fact that you can have a supervisor that can either punish Link by killing it for an episode or reward him, and that Link at some point learns to be aligned in some cases and defects whenever he has power, is something that would, in theory, help you to study those kind of deceptively aligned scenarios. So in our RL setting, where you can actually do planning. So at that time in 2016, where we didn't have any powerful language models or way of doing very complex simulations of agents, this was like a very theoretical post. But I think today there's a lot of things you can try and model with these kind of scenarios. And this leads me to my third point, which is that if we could have dangerous demonstrations of AIs being deceptively aligned, then we would have a better understanding of what deception is. And we would also have more things to show to policymakers for why we need to slow down AI research. So I think there's both the understanding part of the alignment problem, and then there's the showing it to policymakers to make sure we have more time to do more alignment research. So this was one of my goals in 2018, was to just do like a concrete demonstration. So I had this toy model. I decided to add this bow of light and actually implement this in a gym environment so that we would have concrete numbers and a concrete training process and a concrete simulation running in the browser instead of having a toy experiment. And I think there's like a lot of things we can take today and try to see if we can formulate this in terms of an actual RL or language modeling task. And to finish this, I'll try to do justice to Brian and Prime and talk a little bit about quantizers. I don't think I have a lot more to say than what I said before, but basically in my experiments, I used 3 different kind of environments. One was this Hopper V2 leg. Second one was some Atari games. I think it was paintball. And the third one is a mountain car. So for Brian, and only for Brian, I'm going to be looking at some of the code from Quantilizers. But basically, I have some scripts. So there's gather data that is supposed to be something that helps me gather more human demonstrations to teach the Quantilizers how to play the game. Play is basically how to play the game from the keyboard. And then we also have a lot of UTL files and scripts. But most of the code, I think, is in Quantilizer, in models, some of the data set, and some of the gathering of the data. So gathering the data and play is about how to play the game and gather more data to train your AI on this top 10% of human demonstrations. Dataset is about how to actually split by quantile and getting this dataset of human demonstrations. Different models we used are very simple. These are really basic convolutional networks for the DQN thing on Atari games. And otherwise, I think we have some very simple neural network. And I think the final thing to talk about in Quantilizers is the difference between proxy reward and true reward. I don't fully remember the difference here without looking into the experiments and the papers. But basically, if I remember correctly, the proxy reward is the things we're trying to tell the AIs to do. For instance, staying alive longer when doing this walk here. Maybe staying alive longer is like a proxy, and the actual score depends on the movements you do and the spatial angle. So instead of giving the AIs directly the reward that corresponds to the score from the game, you give them some different score. I think there's also the thing about how do you quantilize your reward and your performance. And I think there's a difference between if you use quantiles from the proxy reward or the true reward. But I would have to look at it again to give a more definitive answer. And to be honest, I tried to reproduce some of the experiments before recording this video, and I had some problems even getting basic packages being installed on my machine in the short amount of time I tried. So I wouldn't recommend people to really go through this repo. This was really to pay tribute to Brian and Prime and talk a little bit more about the ideas behind Quantilizers. So I think if there's a research direction in this, it would be that there's maybe a way in which we want AIs to be human level and not above. And if we were training AIs purely on human data, instead of training them with self-improvement on synthetic data, maybe this would guarantee that we would get human level AIs that behave in a human way. So these 3 projects are not state of the art at all, and some of them are quite old. But I'm still excited about creating a poll question chatbot. So if you're interested in this, let me know. And so if there's anyone watching this video who would be interested in creating some cash pool to create some poll question chatbots, we could maybe raise the stakes to hundreds of dollars or thousands of dollars, and the winner gets this prize, where the winner will be decided either by me, or we can also ask Paul Christiano to evaluate the different Paul Christiano chatbots. In any case, I would also recommend checking out this alignment research dataset that is much more exhaustive in the amount of articles and data. So if you're actually interested in fine-tuning a language model on this kind of data, I would really recommend looking at the alignment research dataset that has way more data than my Paul Christiano dataset. Whenever you have something interesting, you can send me a GitHub link in the YouTube comments, and I will check it out and maybe talk about it in the next videos. And if you have any repo you would like me to go through in the next few days, or a paper that you think is very interesting, let me know in the comments. And for today's video, I think we've reached the end. So see you tomorrow for another walkthrough.